quadrilateral PQRS has vertices at P 6 negative 2, Q 4 negative 6, R 4 negative 4, and S 2 negative 2. Part A of the question: on the grid provided, draw the quadrilateral PQRS and its image P1, Q1, R1, S1 under the enlargement scale factor -1/2 and center 0, 0. So this is the first part. So let us, the first thing you're going to do is to plot that PQRS. So we plot that very first. PQRS, you start with P, so I'll draw the X and the Y axis. The X and the Y axis. Let me draw the X and the Y axis. So there you go, the X and the Y axis. So this is the X axis, and this is the Y axis. This is the Y axis. So this is 0, this is 1, 2, 3, 4, 5, 6. This is a -1, -2, -3, -4, -5, -6, -1, -2, -3, -4, -5, -6. We have 1, 2, 3, 4, 5, 6. So the first one is P 6 negative 2. P is 6 negative 2. So 6 negative 2 is here. So this is where we have P. The next one is Q 4 negative 6. Q is 4 negative 6. So we have 4 negative 6 is here. Q 4 negative 6. The next one is R 4 negative 4. R is 4 negative 4. 4 negative 4 is here. So this is R 4 negative 4. And then the last one is S 2 negative 2. 2 negative 2. So 2 is here. And then -2 is there. That is S. So 2 negative 2. Now we have all the points. So you have P. P is there. We have Q is there. R is here. And S is here. So this is where we have S. So we can now join them. We can join those points. So we start with P. We join from P to Q. You should follow that order. Then from Q to R. Then from R to S. R to S. Then from S now you can join, or to S to P, like that. So there is the quadrilateral. So the first question, we are supposed to give the image P1, Q1, R1, S1 under the enlargement scale factor -1/2 about the origin. So the center is the origin, scale factor is -1/2. So scale factor, so the first thing you're going to do, because the center is the origin, we're going to draw straight lines. You're going to draw straight lines, and from each of those points, we start with P. So you join P to the center of enlargement using a straight line like that. Using a straight line like that. Imagine it properly. So from P, using a straight line, you join that straight line. Now to get the image of P, you've joined P to the center of enlargement using a straight line. The scale factor of enlargement is -1/2. So what you're going to do, the easiest way to do, is to count the number of squares from P to the origin. How many squares are these? This is 1 square, 2, 3, 4, 5, 6. There are 6 squares. And the enlargement, the enlargement is -1/2. So if you have 6 squares, 1 from P to the origin, so from this point P to the origin, so 1, 2, 3, 4, 5, 6. There are 6. And since the enlargement factor is -1/2, we are going to divide that one by 2. What is half of the 6 squares? That is 3 squares. So from the origin, we are going to count 3 squares. 1 along that straight line. 1, 2, 3. So you're going to have the image of P here. So this is B. So this point will be P1. Now you can see from this point, from P to the origin, there are 6 squares. 1, 2, 3, 4, 5, 6. There are 6 squares. So because we're enlarging by 1/2, we count half of 6. So you're going to count 3 squares from the origin. So from the origin, you have 1 square, 2 squares, 3 squares. So that is what we have. Then we do the same for Q. We do the same thing for Q. So Q, you join Q to the center of enlargement. Join it to the center of enlargement like that. Join it to the center of enlargement. Then the same way, you count the number of squares that are there between Q and the origin, the center of enlargement. So this is 1, you have 2, 3, 4, 5, 6. There are 6. So enlarging by a half. So from the origin, you're going to count 3 squares. So 1 along that straight line. 1, 2, 3, like that. So you count again. So you have 3 squares. So 1, that is 1 square, 2, and then the third one will be there. Hope you can see how I'm counting. So from the center here, so up to this point, that is 1 square. Up to this is 2 squares. Then this one is the third one. The third one will be there because it is a half of 6. So from Q on Q again, so 1 square, 2, 3, 4, 5, 6. So from the origin you count 3. 1, 2. This is, I'm sorry. So this is from here. 1. You're counting from 0. That is 1, 2, and 3. So this is where you're going to have Q1. So Q1 will be there. You do the same for R. Join R to the center of enlargement. From point R, how many squares? 1, 2, 3, 4. So now we count half of 4 squares. There are 2 squares. So from the origin here, you have 1, 2. So this is how we are going to have R. That is how we are going to have R. This is R prime or R1. So R1 will be here. So the next one is after R we have S. Now you notice that R and S are on the same straight line. They are on the same straight line. So what it means, when I join S to the origin, it will be the same line as the line that I used when joining R to the origin. So the same line, but now the distance will change because now from S to the origin, how many squares are these? They're just 2. 1, 2. From this point to this point, they're just 2 squares. So you have 1, 2. So half of the 2 squares will be 1. So from the origin, just count 1 square. So this is where we're going to have S. So S will be here. S prime will be there. So from that, now we can join the points. So P1, Q1, P1, Q1 is down. Then to R1, P1, Q1, then to R1, then from R to S. Then you join that one like that. So let me use the different colors so that you can see it. So we have P1 to Q1 is there. Then to R1, then to S, and then we have, that will be the quadrilateral will be there. So that is a quadrilateral, P1, Q1, R1, S1. So the first part, we're done with the first part. Now the next thing, that is the next question, is that part B. P2, Q2, R2, S2 is the image of P1, Q1, R1 under negative quarter turn about the origin. Negative quarter turn about the origin. On the same grid, draw the quadrilateral P2, Q2, R2, S2. So the image that we have just obtained, we are supposed now to transform that under negative quarter turn about the origin. So P1, Q1, negative quarter turn about the origin. So the same thing, we are going to start by joining the points P1 to the origin. That is the center of that rotation. Then from there, we measure the angle, negative quarter turn. We're going to measure negative 90 degrees. And negative 90 degrees, we shall measure that one in a clockwise direction. So you take a protractor. This is how you're going to measure that. So after joining P1 to the origin, this is how you place your protractor. So you place it like this. So along that straight line, place it like that. And then since it is negative 90 degrees, you're going to measure that angle in a clockwise direction. So clockwise direction is this way. So when you're placing it on that straight line, the center part of the protractor is there. So, and it is at the origin. So you measure the angle from this point, when this, that is clockwise, negative 90 degrees. You measure it in clockwise direction. So you're going to have 90 there. So from this point, 90 will be there. So that is where you're going to draw a straight line. So let me mark that point. So this point here, this is how we shall have, that is how we shall have 90. So from this point, yes, that is 90 degrees. Then now to get, you can see now this angle is 90. So take this distance from P1 to the origin. P1 to the origin, how many squares are these? 1, 2, 3. There are 3 squares. So you're going to count from the origin again. Should be equidistance. So this is 1, 2, 3. So the image of P1 will be here. So here we shall have P2. We shall have P2 there. So P2 will be here. That distance must be the same. So from P1 to the origin, so how many squares are these? This is 1, 2, 3. So the same number of squares, 1, 2, 3 from the origin. We do the same for Q. We do the same for Q. So you join Q1 to the origin. It is already done. So we did that. Then from there, place your protractor, and this is how you place it. So like that. So measuring 90 degrees. So this will be, so from here you have 90 degrees will be there. So you're measuring from this direction like that. So 90 degrees will be here. So we mark 90. So 90 degrees, so you're going to have 90 degrees. So we join that using a straight line. Then from there, you count the distance or the number of squares. You can measure that distance or count the squares from Q1 to the origin. So this is from Q1, this is a 1, this is a 2, there are 3 squares. So the same thing from the origin, this is a 1 square, 2 squares, so 3. So this is where we have Q2. Q2 will be there. So that is where we should have Q2. Do the same for R prime. So R prime is here, R prime is there. So join R prime to the center. It is done there. So take your protractor, and then we place it along that straight line like that. So measuring 90 degrees, I can see is 90. So measuring the angle from this point going this way, so 90 will be there. It will be there. So let me mark. So 90. So that is where you should have 90 degrees. So join. So from the center, you join in a straight line like that. So now you measure this distance. You measure this distance from R prime to the origin. Measure that distance. You can see how many squares are these. These are 1, 2 squares. Then from the origin along that line, 1, 2. So this is where we shall have R2. So R2 will be there. So R2 will be there. Then since S is along the same line, look at where S is. So S is here along the same line. So we want to give the image of this. So you join it to the center. It is there. We have measured the angle 90 degrees along this line. So the distance from S1 to the origin, that is 1 square. So from the origin, you just measure that is 1 square. So S should be there. So S2 will be there. S2 will be there. I think we have given everything now. We can join. We can join the points. So P1, Q1. So P1 to Q1. Then Q1 to R1 is there. Then from R1 to S1 is there. Then you join now these on this point. So there we have the quadrilateral and rotation negative quarter turn about the origin. The next one is part C. P1, P3, Q3, R3, S3 is the image of P2, Q2, R2, S2 under a reflection in the line x plus y is equals to 0. X plus y is equals to 0. draw the quadrilateral P3, Q3, R3, S3. So now the image that we've just obtained, which is the R2, S2, that one is the image of P2 so the image that we've just obtained, that is P2, Q2, R2 should undergo a reflection in the line of x plus y is equals to 0 in order to give P3, Q3, R3, S3. So one thing that you're supposed to understand, that these kind of, the easiest way, this kind of reflection, y x plus y is equals to 0, it is the same with y is equals to, these will be negative x. And under this reflection, if you have an object point AB that is transformed into negative B, negative A, simply the coordinates interchange and they change the signs. That is under this reflection, y is equals to negative x or x plus y is equals to 0. So in short, the easiest way you're supposed to do this is by simply identifying the coordinates of, let's say, we'll do this one. This is a P2. So P2. So for P2, this is 1, 3, 1, 3. So that one, under this reflection, it will become negative 3, negative 1. So say under this reflection, y is equals to negative x. The point, the coordinates, that is the x and the y coordinates, interchange and they change the sign. Then for Q2 is 3, 2, 3, 2. So that one, Q3, will therefore be negative 2, negative 3. Then R2 is a 2, 2. So the image will be negative 2, negative 2. And then S2 is a 1, 1, 1. So S3 will be negative 1, negative 1. It's as simple as that. Then you can plot these. So we start with P3, negative 3, negative 1. So negative 3, negative 1. So negative 3, negative 1 be there. That is P3. Then Q3, negative 2, negative 3. Negative 2, this is Q3 is there. Then R3, negative 2, negative 2. And S3, negative 1, negative 1. So the points are here. So P3, negative 3, negative 1. And then we have Q3. Q3 is here, negative 2, negative 3. And R3 is here, negative 2, negative 2. And S3, negative 1, negative 1. So we can join those points. You can join them. So P1 to P3 to Q3, then to R3, then to S3, and then you complete it like that. So that is the easiest way to do it, by just understanding that these reflection x plus y is equals to 0 is the same as y is equals to negative x. And that line, alternatively, you could have done that line, and the line y is equals to negative x is this line. Already it is there. It's this line that passes through the center of the axis. This is the line. That is the line. So this one is the line of reflection, and that line is y is equals to negative x. You can draw that line and you'll see that this being the object and the image, they are directly opposite each other alongside that line of reflection. Now after doing that, now we can answer the last question. State the pairs of quadrilateral that are directly congruent. So what do we mean by directly congruent? That those quadrilateral can fit onto one another directly without having to turn them over by just sliding them. So I'd like you to look at them. Look at the three of them there properly. Which ones are going to fit by just sliding them? So just look at them. So when you look at the first and the second, that is this quadrilateral, point it out. So this quadrilateral here and this one. So P1, Q1, R1, S1, and P2, S2. So these two, if you want to join them, you can do it by simply sliding them. When you slide them and just turn them without having to turn them on the other side. You don't need to overturn them for them to fit. You can just slide this one onto these and just adjust. By just adjusting, and it will fit. You don't need to turn it over for it to fit. So this is a very good example of direct congruency. So these and these, for them to fit onto each other, you just need to push this one to this side or this one, and then these points are going to fit P1 and P2 by just sliding it and just a slight turning. You don't need to turn it on the other side, turn it over for it to fit. Just sliding and just adjusting. So that is the first one. So the ones that are directly congruent, so we have P1, Q1, R1, S1, and P2, Q2, R2, and S2. Now what about the ones that are oppositely or indirectly congruent? So these are the ones that for them to fit, apart from sliding, you have to turn them over. Maybe on the other opposite, you have to turn them over for them to fit. And a very good example, when you look at these, look at image 2 and 3. Look at image 2 and 3, image 2 and 3. So we have these and these. So for these image 2 and 3 to fit, when you just slide it along these, or you slide these to these, they will not fit unless you turn it over on the other side. You have to turn it over on the other side, not just sliding and adjusting for it to fit. So for them to fit, either you bring these second image, the third image, or the third image, the first image, and then you turn it. You have to turn it over. You rotate and turn it over for it to fit. So that is a good example. And then the other one, look at image 1 and 3. Also image 1 and 3. Also this one will not fit by just sliding and adjusting. You have to turn over one quadrilateral for it to fit onto the other. So these two. So we have image 2 and 3, and then image 1 and 3. So image 2 and 3. So we have image 2 and 3, P2, Q2, R2, S2, and P3, Q3, R3, and S3. And then image 1, P1, Q1, R1, S1, and the third one, P3, Q3, R3, and S3. So those are the ones that are oppositely congruent.